Hi, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So, in this session, I'm going to explain about the classification of magnetic materials. So, before that, I just want to introduce the magnetic materials. So, magnetic materials are widely used in electrical meters, dynamos, motors, transformers, computers, telephones, tape recorders, television, nuclear magnetic resonance equipments, and particle oscillator. So these devices are very important in our modern living. So the knowledge of origin of magnetism and the behavior of magnetic materials will be of great useful in proper utilization of such devices. So magnetic materials are substances that can be magnetized and attract or repel other magnetic materials. They play a crucial role in various applications from electrical devices to medical equipment. So next, the classification of the magnetic material. So they can be classified into three categories, that is paramagnetic material, diamagnetic material, and then ferromagnetic materials. So paramagnetic materials. So here, when an external magnetic field is applied, the magnetic dipoles tend to align themselves in the direction of the magnetic field. Then the material becomes magnetized. So this effect is called the paramagnetism, and each atom or molecule possesses a net permanent magnetic moment even in the absence of an external magnetic field. So with if we increase the temperature, that increase in thermal agitations disturbs the alignment of the magnetic moments, and uh, in that weak attraction, that is paramagnetic materials are weakly attracted to magnetic field, and the second one is unpaired electrons. So these materials have unpaired electrons causing the weak magnetic response. So the example for this paramagnetic materials, that is aluminum, platinum, and chromium. So if we go for a merit of this paramagnetic material is nothing but the experimental observation of temperature dependence of susceptibility agrees quite well with Curie laws. And then paramagnetic materials exhibit paramagnetism. So that will attract the magnetic lines of forces, and they possess permanent dipole moments, and the value of susceptibility here is positive, and it depends upon the temperature. So next one is the diamagnetic materials. So diamagnetic materials which exhibits the diamagnetism, and they have the properties, that is the behavior of perfect diamagnetic materials in the presence of magnetic field repels the magnetic lines of forces. So there is no permanent dipole moment, therefore the magnetic efforts are very small in these materials. So the magnetic susceptibility is negative, and it does not depend on temperature and applied magnetic field strength. So they are repelled by the magnetic fields. So the diamagnetic materials are repelled by magnetic fields, and it has a no unpaired electrons. So these materials have paired electrons, leading to weak negative response to magnetic field. And the substances, example of this diamagnetic materials are common substances that include water, gold, and mercury. And the next one is ferromagnetic material. So ferromagnetic materials are strongly attracted. So the ferromagnetic materials are strongly attracted to the magnetic fields, and they have permanent magnetized. So they can retain magnetization after the removal of an external magnetic field. And applications, so it can be commonly used in electric motors, transformers, and magnetic storage media. So apart from this, we have the other types of magnetic materials, that is antiferromagnetic, ferrimagnetic, and super paramagnetic. So in antiferromagnetic, these materials have adjacent magnetic moments aligned antiparallel to each other. So ferrimagnetic, they have mixed alignment of magnetic moments resulting in a net magnetization. So super paramagnetic, a small single domain nanoparticles with special magnetic properties. So these are the other types of magnetic materials. Thank you.